Hello everyone, good evening. Thank you for joining in my talk today. So today I'm going to speak about something where if we are working on the resource constrained devices and we are thinking to work upon the AI side, something we need to change if we are using a Zephyr OS, something we need to think from another perspective. Earlier we were having just only legacy cameras where we were just using a streaming and the pictures only. But now if we go into the multiple camera streams, multiple pipelines, everything will get going running into the resource constrained devices. So now if we want to work, how and what changes needs to be done. So let's try to understand by our experiments what we have done. So bit about me. I am Rutvij Trivedi, co-founder and MD of Silicon Signals Pvt Limited. We are an organization which is actively working towards camera designs, and we are working towards customers' camera product design as well as our own custom cameras. At Silicon Signals, we have built a team which is contributes into the Linux kernel, the Zephyr OS, and other such projects which is open source. And we are actively working towards camera side of the contributions. Our team is having a hands-on on the camera, so that's why we are thinking that we share our valuable or whatever our team has done. We share the experience with you. So today we'll talk about these 4 topics. Currently, what Zephyr offers from the video pipeline side, the gaps, what we have identified while working towards camera products building for customer request, some of the solutions we have tried. So far, we have found many missing pieces. However, we are not going to address each and every one. Few we will start step by step and let's see how it goes. And at the end, definitely you might have some questions, so we'll try to address them. This is standard provided by current. So this is the current Zephyr's video segment. If you see from the right side, you will see the video buffer. So this is something video buffer is currently offering. It does not have any flags, sequence number, metadata pointers, which helps you understand that whatever the frame you are receiving, what particular statistic it has, either from the ISP side, either if you are talking specifically about only interference on the NPU side, it does not speak about that. If you see on the right side, it's buffer type we have extended. There are only 2 enums are provided there. It's a bit technical. One is input on one, another is output. There is no other parameter. So while working towards customer requests on the product side of the camera, we have found few gaps which we think that if we are into production, if we are going into the production side, definitely we need to take that into account. Few points are currently there are no metadata pointers available to understand that how the image or frame is going and with what statistics. So if you are working towards AI cameras, if you need to draw a box around your objects, we'll see that what happens if we are not taking some considerations into account. In current Zephyr video APIs, if we see streaming, if we stop stream, it is going to get stopped on the spots, but it does not care about what is going on or any buffers are in flights or not. They are not shutting down the graceful in a graceful manner. No per buffer callbacks. So currently if we see, if we have to NQ and DQ our video frames, we have to actively use our CPU. And here if we are talking about AI cameras to build around the resource constrained devices, it is going to give most of the headaches in the time. And one more thing we found out is a power aware scheduler. So definitely it offers video set frame APIs and notifier, but there is no glue between that. So these are 4 different gaps we have identified. However, we are not going to address each of them. Currently, we have done some prototypes around 2 of these pointers. We'll talk about 2 points which are on the side of the metadata as well as on the side of per buffer callbacks. So this is a current typical application where we use heavily the global variables, and we just think that everything once the NPU does interference, it will be okay. Once we have this particular frame, we try to draw an object around it. This is something a result as we found. Whatever currently we are seeing as a display, it's a n plus 2 frame. It's a n frame, but NPU is currently running on some particular behind the scene of the 2 frames behind. So at that particular time, if we draw a block box on particular object, it will be shifted by 2 or 3 next frames. But this is generally we call a race condition, but it's not a race condition. Why? Is because it's not timely dependent, it's structural dependent. It has a API problem. So API we need to fix, we need to introduce something which takes care of this. Some of the locks even cannot help you over here. If you are aware about the atomic context, if you try to implement that, it will not help us over here. So that's where it's why is because it's not race condition. We have to identify its rates. It's not race, so we have to implement some APIs over here. So it's not this issue what we have discussed is not new issue. It is already present. It was present in Linux as well, and Linux already has some solution we call a meta buffer type. Generally, it is available in the ISP statistics. What it does is when you do have a frame, it attaches the ISP statistics statistics within the frame itself, so that you do have statistics available within the frame once you have this into user space. User space like any libraries, lib camera or something can understand the 3 algorithms and then can perform any NPU related interference on top of that particular frame. So that is one gap. Second gap is we do not have any uh, idea around this NPU interference, how it is going, whether this particular frame has exposed on AE or not, and whether I need to take care of this particular frame for further processing or not. So here is our proposal to get rid of this situation. We want to introduce one particular more parameter called buffer type meta. The RFC is already provided on the Zephyr. So if you are interested to talk more in just this topic, you can go into the Zephyr's issues and then can have discussions going on this particular idea. Our idea is to provide one particular meta buffer as well as ISP statistics structures. We bind them with, we also introduce one more structure called interference result. We do have some data into it. Per frame, we will bind them with ISP statistics as well as on the interference result. And at the last on the video, if we are changing everything, the video structure also has to change a bit. So at that particular video buffer, you add one more pointer, which is if you are using the legacy frameworks, if you don't want to use it, keep as is as null. If you would like to use the metadata and interference result, then you extend that particular pointer towards attaching your frames detail. So this is how we feel that it should be bind into the driver after DMA completion. Before handing over your buffers to the consumer, you attach your metadata information in that particular structures. You find out what is happening. Once it goes actually into the usage, you will get to know that how to work with that. For example, currently we have taken a case where auto exposure we are checking. If the auto exposure is not done, this particular frame is not going to help me with the NPU interference. So we will skip that particular frame. Let's assume that we got very good frame with AE exposures, then we take that particular frame. We do have, and if we see particular structure parameter what we have used, here we are not doing multiple context switches, it's just pointer passing we are doing. So that way we are solving two issues over here. Once on every frame we do have information about the metadata as well as the NPU interference, and not while putting a buffer from one area to another area, we are not doing much of a context switches. So this is something what we are trying to solve with this particular proposal. We have initiated the prototype here, and the RFC is also filed, so you can check the RFC and work with us. So this was the first issue. Now we are talking about the second issue what we have found out. Second issue is something where if you see this particular typical application code, generally currently this is a situation where we just take the frames, we dequeue them, we ask CPU to wake up, and we again enqueue that particular frame to another NP or any other subsystems. So what over here we are doing is just to pass from one FIFO to another FIFO one frame, we are just asking CPU to wake up, but this is for resource constrained devices, it is not going to help us. So here also we have one proposal. Our proposal is to uh, introduce one callback mechanism for having a device attached with that particular information for the frame. Now generally what we do is now a different. You set your callback registers, you start your stream, and you ask your CPU to go into sleep. If you go deep down, once you receive any frame, you process that particular device and data into the NPU and then do a NQ. So now here what we are doing is, here we are saving our CPU context switches overhead. So this is something we can achieve via this second implementation. So there are two proposals we are currently doing. This particular solution has been done as a part of prototype. My colleague had helped me to validate this particular prototype. Still, it is under. It has to go through certain test cases before if before even we file any RFC or before we file any patches to the Zephyr active communities. So this is something where once you do have that callback, how you perform with that callback should get active via the DMA. You check whether if it's a legacy implementation or newer implementation. If the callback is assigned, you do your work on the callback k work thread. It's now into the threaded context, so no ISR and no logging problem you will face. We have currently done this experiment on STM hardware, and this code base, if you are seeing, that has been taken from the ST's hardware snipped only. Now, one argument is why that cannot be done into the kernel, that cannot be done into application or any other layers. But what we believe is, as far as our experience says, the frame whatever we are receiving, these two proposals should go into the kernel itself. Why is because you directly want that particular frame what is get attached with the ISP statistic to get processed next. So that is where we think that it will be a more sensible area where if that particular implementation if we keep into the driver code itself, then it makes sense. Any other areas will again give some conflicts over there. So we are proposing that particular two solutions to be adapted into the kernel itself. So there is a kernel change we are proposing. However, it's under discussion that even we have seen that many vendors who have their own different ISP will have a different statistic mechanism to populate. So we cannot bind into a single structure. So how to tackle that is again a question that is yet to be solved. So these are proposal. Why we have not directly patched it is because we have to go through certain discussions. We have to come up with certain areas to find out whether it is fixing the problem, it is fixing for all the vendors problem or not. So that is the reason why currently it's in RFC. We already have patches, but it's not under the condition where it can be submitted. So this is a snippet of RFC. If you would like to contribute into the discussions and talk, the issue number is given. So definitely join us to contribute into the discussions. Once we get to any conclusion, definitely the patches can go. As per the modification given by the RFC people and the community people, we will welcome them. So I would like to close over here by saying that whatever the proposal we have given, it's under RFC. We'll definitely discuss. The patches are available, the prototypes are available, but still they are under discussions from our side itself, from our team side itself, but open for communities feedback. We don't want to create Zephyr next Linux, but we are trying to see that whatever the abstraction layer we can find, keeping the Zephyr lightweight and keeping the Zephyr motive going ahead. We just take those implementation. The going forward future is okay, of course going to be on the cameras, and for any cameras and any AIs if you need. So certain level of the legacy thinking has to be changed. Currently, majority of the implementation kept in mind with a single pipeline only, but nowadays with coming with new SoCs, new chipsets, resource constrained devices are also equally becoming NPU and multi-pipeline complex camera features. So that's where this implementation will help. I would like to provide my credits whosoever helped me while preparing this presentation. One is my colleague Elgin, he's here. And another is from Joshua from a media maintainer community from Zephyr, a video community maintainer. So who has helped me. So these are the all discussions you also can find in the Discord. If you would like to contribute into that particular discussions, you are welcome into Discord as well. So I think I'm at the end of the presentation. If any questions for me, definitely would like to answer them. Yes, please. I hope that I can take the questions. No time? I think no time, right? Sorry? Uh, no, basically what we are doing is still it is under RFC and discussions. So what we are doing is with community on Discord and the issue filed on the Zephyr Git itself. So now it's not something which is available right now. Even in fact, there are some gaps even we are finding. So we are discussing with the people. We would like to, so this is something a prototype problem and concept. Now it's not ready yet. So it cannot go into the Zephyr mainline. So what we expect is let's contribute, let's see how it goes, and then we can, do a PR and then can merge it. Thank you. Anyone? Yes, please. We have tried. In fact, there are multiple other options are also available. For example, we mentioned about this per callback, right? RTIO and KPOL. I think they are something which is currently helping us. However, KPOL, if we see, is currently helping us to understand that whether the frame is arrived or not, but not they are specifically mentioning that at these particular frame NPU has done interface and now it is ready. So that information we need. So for going forward with information, it will help. So that's why we are proposing these new ideas. I hope that I have answered. So how about we discuss hallway, because other people may be waiting for times. I think I have taken much time. Thank you very much. Bye.